This task carries on from the last, and 3 computers or virtual machines should be communicating as shown. In our example, we used a Linux server, a Windows 10 and a Windows 7 machine. So what is Samba all about? In brief, SMB or Server Message Block is a protocol that is used between a Microsoft client and a Microsoft server. When the client requires access to the shared resources on the server, it sends out an SMB request and the server responds with an SMB acknowledgement. Linux operating systems do not support SMB by default. Therefore, a compatibility system called Samba was created to allow shares between the two systems. The commercialization of the internet over the past few years has created something of a modern melting pot. It has brought business folk and technologies close together than was previously thought possible. As a side effect, Windows and Unix systems have been invading each other's turf, and people are expecting that they will not only play together nicely, but they will share. A lot of emphasis has been placed on a peaceful coexistence between Unix and Windows. Unfortunately, the two systems come from very different cultures, and they have difficulty getting along without mediation. And that, of course, is Samba's job. Samba runs on Unix platforms, but speaks to Windows client like a native. It allows the Unix system to move into Windows network neighbourhood without causing a stir. Windows users can happily access files and print services without knowing or caring that those services are being offered by a Unix host. All of this is managed through a protocol suite, which is currently known as the Common Internet File System, or CIFS. The name was introduced by Microsoft and produces some insight into their hope for the future. At the heart of CIFS is the latest incarnation of the Service Message Block, SMB protocol, which has a long tedious history. Samba is an open source CIFS implementation and is available free from the following web address. Indeed, Samba is so versatile almost any device that supports a version of Linux is compatible, which includes mobile phones, tablets and laptops, etc. In this task, the Windows 10 client is used in some part to set up the Linux server using webmin. One problem here is that the Linux server requires an access to internet to install Samba, and at present the Linux server is using an internal network. A solution to this would be to change the configuration of the network adapter to NAT in VirtualBox, thus allowing access to the internet, installing the required files, then changing the configuration once again back to internal network. However, we'll take this opportunity to demonstrate that computers can access different networks even on different addressing systems. First, close all virtual machines. Restart the Linux server and check that it runs without any errors. Next, we need to install in the Linux server a second network adapter and configure it for NAT within VirtualBox, then configure the Linux server for DHCP. Shut down the Linux server using sudo halt. Select the Linux server in VirtualBox, then click on Settings, Network, then on Adapter 2 tab. Select Enable Network Adapter and attach to NAT. Check Advanced that the cable connected has been selected. Click on OK, then start the Linux server. Check the name of the network adapters using the following command. In our example, it has returned NP0 S3 and NP0 S8. Now to edit the interface file using the following. Set the new adapter to DHCP using the following script. Since we should be continuing from the last task, no other amendments need to be done. Save and exit using Ctrl+X. Type in Y, then enter when prompted to leave the current file unchanged. Restart the Linux server using sudo reboot. Update the server. To install Samba, we can use the following command. And when prompted with "Do you wish to continue?" type in Y. Samba requires a password to allow users access to the shares. Once the download has been complete, type in the following to add a new password. We could have stipulated other users at this point, but since Janet is the only one with an account, we shall use her. You will now be prompted with a new SMB password. This could be anything, but for simplicity's sake, we shall use "Let me in" again in lower cases. You will then be prompted to re-enter it. This completes the Samba installation. We could continue on the Linux server and complete creating the share folders, etc. But we shall demonstrate at this point how versatile webmin can be. Remember, the client running webmin could be on the other side of the world. So we shall create new shared folders on the Linux server using webmin on the Windows 10 machine. This should already have an internal network adapter installed within VirtualBox. When Windows has installed, click on the Internet Explorer icon, then type in the following link. In our example, we just clicked on refresh and we was prompted to log in using the admin for the username and "Let me in" for the password. After a few moments, when webmin appears, click on Others found in the left-hand menu, then on File Manager. Click on Create Directory icon. In the new directory name, type in Shared Folder Server. Notice there's no capitals. Remember that Linux is case sensitive. Click on Create. At this point, we have created a directory or folder on the Linux server remotely using webmin. If we check the ownership, it is root. This means the user that has permission to access the directory is root, or the admin of the Linux server. This user is in a group called root. Without going into users and groups at this stage, we must try and understand that the administrator of one computer does not automatically give that administrator the same rights of another administrator of another computer. We can think of it like this. Two houses next to each other. Both have a family by the same surname, Smith, but the door keys are different. So if Mr. Smith from one house wishes to enter his next door neighbour's house, then he must borrow his next door neighbour's keys. Similar to our situation, just because the two administrators are called the same does not mean they both have the same rights on both computers. Again, to simplify things, we shall call the user Janet and the group name Janet. To do this, we click within the box to the left of the directory we created called Shared Folder Server, and click on the icon called Shown or Change Ownership. In username, type Janet, and in group name, Janet. Once again, notice no capitals. Click on Change. This should have caused the user and the group name to change to Janet. Samba works on referring to a file to tell it the name of the directory or folder, where it can be found, who can access it, etc. And this can be found in a file called samba.conf. To configure the samba.conf file, we have to navigate to it by clicking on the directory etc. Click on Pages 2, scroll down, then click on the directory called Samba. Click on the pen icon to the right of the file called samba.conf, and this will allow you to edit the file. At the end of this script, type in the following. Share name. Tell Samba that the next part of the script, the name of the shared directory. Path equals / shared folder server. This is the location of the shared directory. Available is equal to yes, or we could hide this from all other users. Valid users equals Janet. This also could include other users if their accounts existed. Read only. No. In other words, the files within this directory can be read by any user. Browsable. Yes. So other users can browse through this network. Public. Yes. Others across the network can also see this directory. Writable? Yes. And the files found here can be changed and new files and directories be created. Scroll down to the end of the file and click on Save and Close. Now to restart Samba with the new COV file, click on the command shell found in the left-hand menu. In Execute command, type in the following. Then press Enter. After a few seconds, the Samba service should have restarted. Samba should now be ready to allow users to use the space we have allocated on the Linux server. To demonstrate this, we'll use the Windows client. In our example, we have chosen Windows 7. First, check that it has been configured in VirtualBox for internal adapter. Then start the machine. When Windows is initialized, right-click on the network icon found on the taskbar. Then click on Open Network and Sharing Center. Click on Change Adapter Settings, then right-click on Local Area Connection, then on Properties. Double-click on IPv4, then change the IP address to 10.10.1.4 and the subnet mask to 255.0.0.0. Click on OK, OK again, then close all windows. Next we shall create on the Linux server a new folder using the Windows 7 client. Click on Start, then Computer. Double click on Network. Double click on Ubuntu. As we said before, Samba uses a password, and this was set earlier within the task. Type in the username Janet, and for the password, let me in. Here we shall find a folder called ShareName. This is like a shortcut to the directory we created on the Linux server called Shared Folder Server. We should see this effect now. Within the folder called ShareName, create a further folder called Created on the Windows 7 client. Change back to the client running webmin. Then click on the file manager found in the left hand menu. Double click on the directory Shared Folder Server and we should find that the directory that was created on the Windows 7 client. Now let's create a new directory called Created on Windows 10 client. Click on the new directory icon found in the top right hand side. In Create, type in Created on Windows 10 client, then click on Create. This should have appeared. We can now see the effect on the Linux server. Change to the root directory using cd/. Use ls to list the contents of this directory, and we should find the directory called Shared Folder Server. Change to this directory. And once again, list the contents. Here we should find the directories that were created on the other two clients. This has just been a simple example of what Samba is capable of, and any device that supports Samba, whether it's a PC or a mobile phone, can exchange files, folders or directories.